18.1b. This section was about reference angles and, of course, still drawing angles, which we did the day before. I was grading papers. Well, not papers. I was grading assignments online thinking, I would so much rather be doing math than grading math. So I said, oh yeah, I haven't done any problems yet from 18.1b. I'm sure you all feel just as excited when you suddenly realize, oh, I'm tired of English. I'm tired of history. I have some math I could be doing. Yeah. Okay, well, that's the way I feel about it. I'd rather be doing math than grading math. And I usually pick out even problems to do for you. But some of these here, I found that the odds were just more interesting problems. So I'm going to do some odds today too. We're drawing an angle using the measurement they give us. And we're going to state the reference angle in degrees or radians depending on the original form. If it starts with degrees, we're ending up with degrees. And that's the first 6 problems. And then I think we have 6 of them that are in radians. So we'll have to state our reference angle also in radians. And then we've got some converting between. If you really hate radians, you can convert between first. Let me do some of those converting ones first, just for those of you who hate the radians. I don't know why. They're just a little bit of fractions, but they're okay. Remember that 180 degrees is equal to pi. Both of those are half a circle. So I can make a fraction that has 180 degrees over pi, or I can make a fraction that has pi over 180 degrees. And both of those are really the same value top and bottom. So both of those really equal 1. They won't change the value of what I'm working with. It'll just change the way it looks. I'm going to look at number 14. And since it starts with a pi in it, I'm trying to get rid of the pi and change this into degrees. So pi in the bottom, 180 degrees up here on top. And I need to do a little canceling, get rid of my pi's. See, does 4 go into 180? Well, I could do it in 2 steps. 2 goes in there twice, 2 goes in there 90, and then 2 goes in there once, 2 goes in there 45. I end up with 45, and don't forget, I've just changed it into degrees. Times that 11. So 45 times 11. Have I showed you this class my 11's trick? Here's my 11 trick. 45 times 11. 45. 4 plus 5 is 9. 495 degrees. Oh, I love that little 11 trick. Let me show you another one with my little 11 trick. If I had 32 times 11. 3, 2, 3 plus 2 is 5. If I had 57 times 11, it becomes a little trickier. 5 here, 7 here. 5 plus 7 is 12. Can't really just write the 12. So I put the 2 here, make that up into 6. Okay. I have to tell you, I was not a big fan of math until I had a teacher who started showing me some tricks, because I hated memorizing times tables. I know some of you just love memorizing times tables. Then math changed, and I say math got better, and some people say, no, they started throwing in letters, it got worse. I say, they started throwing in letters, suddenly it became worthwhile memorizing my times tables. Okay, can you tell it's late at night? I'm just rambling about how much I love math. Okay, we're going to look at number 18. Number 18, I already have degrees this time. So I'm trying to get rid of the degrees. I'm putting 180 degrees on the bottom, and I'm putting pi up on top. This time I'm going to get rid of the degree symbols first. And maybe I'm going to say divide by 10 gives me 18, divide by 10 gives me 57. Does anything go into 57 and 18? 5 plus 7 is 12. 3 goes into that, so 3 goes into both of those. 3 goes into here 6 times. 3 goes into here 19 times. So we end up with 19 times pi is 19 pi. 1 times 6 is 6. I think that's enough of those. Those really are not that hard. Just have to say, if I'm trying to get rid of the pi, I multiply with the pi on the bottom and the 180 on top. If I'm trying to get rid of the degrees, I multiply with the degrees on the bottom and the pi on the top. Some of those ones are sloppy, but I think you know what I mean. Let's go back to the beginning. Just in case you happen to hate radians and you want to transfer between them. Every single one of these problems, I'm going to start by drawing the initial ray. And the fact that there's already a ray drawn doesn't get you out of drawing that arrow in right there. I'm going to put it in for all of this. There we go. Initial rays on every single problem. I'm going to be drawing a negative angle, and I want you to remember that. If it's positive, we go up first. If it's negative, we go down first. Okay, this is if it's negative. This one is negative. So I'm going to start with heading down. And you can tell that's more than 360 degrees in the negative direction. So I'm going to start here, and I'm going to do around. Make sure you don't come back to the exact same place because we have to have room to continue our spiral. I have negative 595 degrees, and I just drew 360 degrees of that. That leaves me with negative 235 degrees. Let's put that in a different color. Negative 235 degrees. So I've written it before. This is what I need. This is what's already done. And this was what I have left. Negative 235 degrees. Let me go back and put some measurements on this picture. I will start with 0 degrees, 180 degrees, 360 degrees. Those measurements are not necessary, but they make it easier to see what's going on. Which means since they're not necessary, sometimes I'm lazy and I don't put my degrees on it. But I know I really should. I'm continuing in this direction, in the negative direction. And so I'm going to say, what if I do that much more? So I just did 180 degrees. Which leaves me with negative 55 degrees left to go. If I went exactly to the center here, that'd be 45 degrees. I need to go a little further than that. So I'm going to go over right about here somewhere. A little bit past the center. Put an arrow out there. Put an arrow right there. And there we go. A full circle around, a half circle around, and 55 degrees more. There's my negative 595 degrees. We need to also label the reference angle. And the first day we talked about drawing these angles, I said, when you get done, I need something telling me where you are. Preferably, how far am I from the nearest part of the x-axis? And it looks like that one is definitely closer to 180. So I'm going to think about, what is this space? And we already said we did the green 360, the blue 180 and 55 more. 55 degrees more. So my reference angle, 55 degrees. And it doesn't matter if it's up or down from the x-axis. Reference angle is always a positive answer. I think that's all I want to do from that first set. I'm going to the next page. And look, magic. I already drew in the initial rays on all those too, so we wouldn't forget they have to be drawn in. They have to be clearly heavier than the original lines. I'm going to look at number 7 because I want to look at a radian one. Now, I don't have my circle beside me, but that's okay. I don't need my circle. If you find that you want to look at that circle to give you an idea of where things are, you can do that. I'm going to start with 0. Pi instead of 180, and back to 2 pi. Now remember though, that I need to have something in fourths, so I can figure out where 13/4 is. So instead of having pi, I'm going to change this to 4 pi over 4. It's still equal to pi, but it's in fourths. And I'm going to change this 2 pi into, if that's 4 pi over 4, double it and call this 8 pi over 4. Remember, when you double it, you only need to double the top. The bottom stays the way it is. And that is actually over 4. So I have to do 13/4. And if I positive, so going up, started here and went all the way around, I'd have 8/4. So I started with 13/4. And I drew 8/4, which leaves me 5 pi over 4 left to be drawn. If I draw another half a circle, that's 4 pi over 4, but I need 5 pi over 4. So I just need 1/4 more. Let's go back to the beginning and think, if half a circle is 4/4, what's a single quadrant, a fourth of a circle? That's 4/4. This would be 2/4. And what I want is 1/4 more. So if I go to the exact center of that, I will have 1/4 more. Here's my angle. I want to look at a different way to do that. What if I took my 13 pi over 4, instead of those other calculations that I did, I said 4 goes into 13 3 times, 1 left over. Then I could just say I need 3 1/4 pies. I'm just going to draw it separate so we can look at it briefly. And I could say here's 1 pi, and here's 0, and here's 2 pi. And I could just draw my circle by saying starting ray, 1 pi, 2 pi, 3 pi, and then just 1/4 of a pi, which means 1/4 of that space. Another way to think about it, some people think that's easier that way. It comes out the same at the end. Go on to the next page because I have some more good ones. Oh, no. Forgot my reference angle. How far did I go down here? I went 1/4 of pi left. So my reference angle, pi over 4. Next page. Did I go too fast? Pi over 4. On this page, I want to do number 9 and number 12. Okay. I'm going to use that technique that I just did, and I'm going to say 43 pi over 12 is going to be 12 goes into 43 3 times. 7 left over. So 3 and 7/12 of pi. Okay, I went back and put the initial rate in all of them. Notice that I also put a space for reference angle in all of them. When you go to check this, I think if when you're looking at just the answers that are printed on page 3 of the worksheet, the odd answers, you'll find that they didn't put in the reference angles, and then I had to add the reference angles later, because the program I used to write this won't let me alter the answers or alter anything about problems where the answer is a picture. So I had to put them in there later, but I wanted to make sure we didn't forget them as we were working through this. So I'm working on number 9, and I'm going to say, here is pi, here is 0 and 2 pi. Since we're dealing with 12ths this time, this becomes 12 twelfths, and 12 times 2 is 24. We'll call this 24 pi over 12. If I think about it using this, I could say I need 3 and 7/12 of a pi. I need 1 pi, 2 pi, 3 pi, and 7/12 of a pi. Well, I need to stop and think about if half a circle is 12/12, then a quarter circle is 6/12, which is half of a pi. So if I want another 7/12, I'm going to need here's 6/12, and that would leave me one more 12th to go. If there's 6/12 in a quadrant, I need to be just a 1/6 of the way into this space. So what I drew right here, the green part, is 7/12 with 6 pi over 12 here, and 6 pi over 12 here. Now the question is, how far did I end up from the nearest part of the x-axis? In this case, even though it was coming from this side, I'm not closer to this side. I'm over here closer to this side. So I'm going to say, how much is left to get up there? Well, if out of the 6/12, I went 6/12 and one more 12, that means I really have 5/12 left in this space. 5 pi over 12. And look at number 12. Reference angle number 12. Negative tells me I'm going to go down, and I need to know how far that is. 0, pi, 2 pi. Because it has 9 on the bottom, I'm going to make that pi into 9/9 of a pi. And 2 times 9 is 18. So this is turning into 18 pi over 9. I need to go 1/9 down. If half a circle is 9/9, I need to be 1/9 of that half a circle. If I'm looking up here, I'll say half of 9 is 4.5, and this is very strange to write it this way, but 4.5 pi over 9. So if I'm looking at this space, this space in here, every quadrant has a space of 4.5 pi over 9. So if I want to go down just 1/9 of a pi, that means I'm going to go down just a little bit. And I don't know what happened, but something moved. And I need to make sure this ray looks like it's actually on the line. Things just kind of shifted up along the way. Things get caught and move when I'm not trying to do that. So I'll just make them a little wider so they actually look like they're on the line. So then the question is, how far down is that? It is down pi over 9. But even though it's down, the reference angle gets stated as a positive difference. Next page. I already did some of these together. Don't think I need more of those. These were actually in our notes, but they're a good stretch, slight stretch from what was in our notes. This time the angle is drawn for you, and we need to figure out what the measurement of the angle is. They did their initial ray and their ending ray in blue here. If you print this out and you don't have a color printer, if I had printed it out for you in class, it would have been all black and white. But I like having it in color so you can see what's going on. I'm looking at number 22, and I'm trying to say, what is the measurement of this angle? And the first thing I'm going to do, because I tend to lose track of it at the end, is say, if it's going downward, it must be a negative angle. I don't want to lose track of that fact. So I'm going to say 0, pi, 2 pi. Since this has 4 on the bottom, I'm going to call my pi 4/4 of pi. And 2 times 4 is 8. So I'm going to make my 2 pi into 8 pi over 4. If half a circle is 4/4, then a quarter circle is 2/4. So every quadrant is 2 pi over 4. So if I'm looking at this curve, it contains a 2 pi over 4. And it contains another section here that is just pi over 4. 2 pi over 4, one more pi over 4, 3 pi over 4. That's how long this whole curve is. But because it went down, not up, it's a negative 3 pi over 4. Let's look at number 19. Number 19 has a lot of spirals in it. I like that. I know that my final answer is going to be positive because it's going up. Do not need the plus sign, but that reminds me at the end that I've already thought it through. So I'm going to start at the beginning, which would be the innermost part of the spiral, and say, going all the way around. That is a full circle, and a full circle is 2 pi. But I've got some fractions going on here, so I'm going to stop and think 0, pi, 2 pi. Because the given fraction has an 18 on the bottom, this becomes 18 pi over 18. And double 18 gives me 36 pi over 18. So when I'm looking for what's actually making up this angle, I'm going to say this angle includes a full circle, looks like another full circle, so another 36 pi over 18. And a little bit more than that. How much more? They told me this part. That's not in here. So I'm going to have to think about what's a quadrant. If half a circle is 18/18, then a quadrant would be half of that, 9 pi over 18. That means this whole space here is 9 pi over 18. But I don't want the whole thing. I want this piece. That's 9 pi over 18. 7 pi over 18 is not in it. That means 2 pi over 18 is this space, which does happen to be 1/9, but don't bother to write it that way. We're going to come over here and say 2 pi over 18. 36 and 36 is 72, and 2 more is 74 pi over 18. But I do want to look at this and say what goes into 74 and 18. 2 goes in there, 9 and 37. Nothing else goes into there. So the total for this whole thing, and we remember that we started with saying that it's positive, so 37 pi over 18. Should I do a degree one even though I've already done 2 from this section? Yeah, I think so. Let's do number 20 also. What do we have? Degrees. 0, 180 degrees, 360 degrees. And then we say it's going upward. So my final answer is going to be something positive. It goes up and around a full circle. So it goes 360 degrees around. And then it's going around again, but it's not going all the way around this time. So I'm not going to be using another 360. I'm going to say 90, 180. So I know there's 180 degrees more. And then I know that half of 180 is 90. So a quadrant is 90. That means this space down here is 90. Out of that 90, 35 of it is outside, which means 55 degrees of it. And it does look like a little more than half the quadrant. 55 degrees more of it is right here. So plus another 55 degrees. And then I have to add up all those numbers. Turns out to be 595. 595 degrees. Then I'll leave you one of that section to do yourself. Okay, so I just did for you 1, 2, 3, 4, 5, 6, 7, 8, 9. I just did 9 problems for you out of 22. If you still really have troubles with the rest, do that. The reason that this time I copied the heading with this in it is because I want to start being really picky about this. Just too much going on here. I've had other teachers tell me that they think people are just taking a photograph of somebody else's paper and turning it in. So I want you to start making sure not only is your name on your paper, because I've always asked for that, but you haven't always done it. Make sure your name is on your paper in ink, please. And if it's on 2 pages, put it on both pages. Name in ink just makes it that much harder for somebody to take a picture of your paper and use it for their own work. If you do all that work, you don't want somebody else to be taking credit for your work. Okay, I think that's enough for now. If you have something else you really need help with, let me know.